Myself, Dr. Rajiv Mishra. I am from IIT Patna. The topic of this lecture is design of key value stores for IoT edge storage. Content of this lecture. In this lecture, we will look up the need for design of a data store, that is databases for IoT applications. In this lecture, then we will discuss the design and insight of these key value or NoSQL stores that is used for today's edge storage system. Then we will also discuss one of the most popular cloud storage system, that is Apache Cassandra, and the different consistency solutions which may be required for different IoT applications. So, let us get started with the simple illustration of a data flow in an IoT system. So, initially the data is collected from Azure IoT sensor, that is shown over here as a representative figure of all the IoT sensors. These IoT sensors used to pass through the IoT edge gateway, and then we need to pull the data from IoT edge using stream analytics and then stream that data to and from IoT edge to the data store or the databases. So, this particular IoT sensor is the source of this particular data in an IoT system. This particular data will be now go through the IoT hub, that is a gateway, or you can also say that it is an IoT edge. After that, it will be used for the stream analytics, and then this particular data will be stored in the database for further actions on it. So, therefore, for every IoT system, you may require an appropriate data store or a database, and we have shown you that IoT sensor through the edge, that is IoT edge. In this example, we have taken Azure IoT hub. So, Azure IoT hub is having the edge offering also. So, cloud and edge, both the offerings are there, and then there will be using that in stream analytics, and finally this particular data will be stored into the database, whether this database will be at the edge or at the cloud, depending upon that situation. We will discuss this in more detail, how different technologies will provide this kind of sensor data storage. So, this is an overall data flow diagram. So, you can see there is an edge, there is a public cloud, two entity, and here we can say it is a things. So, you can see that the IoT sensor, which is embedded across all the things, will be the source of the data generation. So, the data will be now either using the data ingestion technologies like Kafka, or using telemetry, that is MQTT protocol and REST APIs will be used to pull the data out from the sensor source, and then it will be taken up into an edge oblique public cloud system. Now, you can see that this particular data often is called a time series data, and this particular data sometimes require as the analytical data for the different purposes. So, this data, where once it is inside the system, immediately if it requires the processing, they are called the hot data. And for this hot data, there is a requirement that storage has to be scalable horizontally. So, therefore, this particular type of situation is called the edge data center, will provide the elastic data store at the edge also and support the data locality. Now, crossing this edge, when the data moves into the public cloud system, this particular data will be stored somewhere into the data store, and that is also using the technologies which is called data lake. So, once the data is stored somewhere, it becomes the issue for cold data analytics. So, cold data analytics also requires sometimes these availability and horizontal scaling. So, that particular data store also requires these kind of situations where you require the enormous amount of resources somehow, because you can see that hundreds and thousands of IoT devices are sending the data through the edge to the cloud. So, you require both at the edge horizontal scale based the data store. Similarly, at the cloud also you require that particular system. So, these kind of system which supports this horizontal scaling or scalability is called the big data platform. So, big data technologies are supporting this kind of data store which is used for an IoT edge system. Now, then we can see different kind of connectors are very much needed. One is the connectors for the public cloud store and the big data store. Similarly, for data ingestion also you require a connector. Similarly, for big data store you require a connector. So, all these are specified here into the public cloud system. Finally, these particular data which is stored can further be used for model training and performing the analytics, whether it is real time analytics, if it is a hot data analytics, or it is the cold data analytics where you can get the insights at later stage, and then after the insight actions are to be derived for business intelligence. So, therefore, let us get started into more detail about this. So, the most popular databases for IoT applications are InfluxDB, CreateDB, React, MongoDB, then RethinkDB, SQLite, Apache Cassandra. To select the right storage for the time series data and in the IoT domain use case, it depends upon the data access methods which is given as follows. So, hot database means typically used for the data that is frequently being queried and updated, and as the data enters into this system of edge and cloud, these kind of queries or analysis is to be supported instantly. So, they are also good choice for storing the data as they provide read and write capabilities with little latency at a low cost. So, when choosing the hot database, we have to consider several important features such as querying ability, messaging, queuing capabilities, tiered memory models, and so on. Now, the next important store is called cold databases. So, they store the information in their original state with little to no changes made thereafter. So, in contrast to the real time data store, these kind of data which is called cold storage requires the huge storage volumes and often being used for model training of a machine learning models at a later point of time. So, now let us go into more detail about cold storage data. Cold databases will use the technologies such as NoSQL with a built-in sorting. So, the examples of such technologies are Bigtable, HBase, Cassandra, DynamoDB, and they are often used to store the time series data with a huge volume involved within it. So, this particular kind of storage which is required for IoT system, they are extremely and well scaled for the writes. And these particular different kinds of analytics are not supported and not efficient sometimes, but nevertheless it gives a way for scalable writes in very efficient manner. So, NoSQL purpose built time series databases are also available. So, there are several engines which supports for time series databases, and most of them are NoSQL. So, we are going to discuss them in more detail. New SQL in memory databases. So, in memory nature of SQL databases increases their ability to handle fast data ingestion, SQL interface enriched by the time bucket normalization support, and so on. So, these are very much required for supporting up as the infrastructure for analytics capabilities. So, the cloud time series platforms which different cloud vendors they support, such as Azure and AWS, they have recently released their similar databases, that is called Azure Time Series Insight and Amazon Time Stream. All these platforms supports time series data storing, visualization and other capabilities for querying. Now, they have been built in separation of the data between hot, warm and cold storage to make the data store and retrieval well balanced from the cost of ownership perspective. Let us see this kind of example of such situations. So, in this continuation we are considering, let us say, a use case of IoT data analytics, and let us use a fitness tracker. Normally it comes as an IoT gadget which people can wear, and then this particular sensors within it can send the data which is now further processed as the IoT data analytics. So, the data set consists of a set of observations, such as this particular data will contain the metric name generated by the sensor or edge, such as heart rate, elevation, steps and so on. These metric values which are generated by this sensor bound to the point in time. So, therefore, time stamps are also to be attached with these kind of fitness tracker generated data set. Now, the tags and the context description in which a given sensor is generating the data, such as device model, geographic location, user, activity type, is also to be included by these IoT devices. Now, then this particular data requires some functional needs for data retrieval. So, let us see a very basic level of data retrieval includes the random data access for a particular point in time and return the proper metric value. Similarly, a small range also sometimes based query is needed and return the sequential metric values. Middle level, that is the time window normalization applied technologies or techniques to be supported for the measurement events usually supposed to be triggered on predefined recurrence basis, but they are always deviation in the data points timings. That is why it is highly desirable to have these capabilities around and predefined time windows to normalize this time series data. So, mid level database capacities such as flexible filtering and flexible aggregation, this is sometimes needed. For example, when you say flexible filtering, we mean that filter the data point based on predicate on tags and context attributes, that is filtering data points by some region, user or activity type. Flexible aggregation, we mean that grouping and aggregation on tags and context or their combinations, that is maximum heart rate by region, activity type and so on. Whereas the advanced level requirement comes in the form of sequential row pattern matching and checking if the sequence of events matches the particular pattern to perform the introspection and advanced diagnosis. So, diagnosis includes some of these questions which require to be answered during the analysis stage, did some pattern of measurement precedes specific event, what measurements might indicate the cause of some event such as failure. So, all this is required an analysis into the time series data, and that requires the storage which has this kind of querying very efficiently or retrieving the data efficiently. So, therefore, it requires stable storage, ability to handle big volumes, it requires a scalable writes, that is ability to handle the big amount of simultaneous writes. So, this is closely related to the real time data access, and then it is also to be supporting the scalable reads, that is the ability to handle big amount of simultaneous reads and high maturity, that is in the presence of market and community. So, therefore, let us discuss a particular design of databases which can support all these functionalities, and that is called key value abstraction. So, what do you mean by the key value abstraction? The key value abstraction means that there is a key associated with the value, that is the data store is organized in this particular form, that is key value store. So, what do you mean by the key for a particular business? We will see that if it is a flipkart.com, key means the item number and value means the information about those items. Similarly, if it is a easemytrip.com, the key means that flight number and the value means the information about the flight availability and all other details. Similarly, twitter.com, the key will become the tweet ID and the information about the tweet. mybank.com is an account number and the information about it. So, this key value store becomes a dictionary data structure which supports the operations like insert, lookup and delete by key, and these typical examples are the hash table or the binary tree. But this particular dictionary data structures, what is needed here in this particular situation of supporting the IoT data store and also of a big size, that is a big data store using supported by the big data technologies. So, they are required to be distributed. So, that kind of data dictionary data structure which is centralized is not going to be used in the IoT data store, it has to be a distributed one. So, the distributed data store which supports this distributed technologies is that the distributed hash table implementation, but that is on the peer to peer system design. So, the design of these data stores are quite different and they are called distributed hash tables. So, key value store reuse many technologies from the distributed hash table, so that we are going to see. So, it is a kind of database such as relational database management system was there around for the ages, and MySQL is a popular interface of accessing it due to the very close to all the programmers around the world using this MySQL interface. So, data is stored in RDBMS in the form of table, schema based it is, and each row in a table has a primary key that is unique within that particular table and is queried using structured query language and supports the join. So, this is the traditional RDBMS we have talked about, but this is not going to be used or useful in this IoT data store which requires a big data technologies for these databases. So, in the relational databases, you know that the tables, the data is organized in the form of a tables, and these tables are called, one of these attribute is called the primary key, and one more attribute is called the foreign key, which will become the primary key of another table, and it supports the join operation. But it will mismatch with the today's workload, which is an IoT data store workload, which is categorized as the IoT data which is large and unstructured, that is come out with the schemas where the data can fit. So, this particular type of workload has lot of random reads and writes coming from millions of IoT devices. Sometimes they are write heavy, and the foreign keys are rarely used and join is infrequent. Therefore, the today's workload, which is an IoT all data, is requires a speed and avoid a single point of failure, and also it is a low cost of operation to the ownership, fewer administration, and incremental scalability, scale out and not scale up. So, when you say scale out, that means it is horizontal scaling. Horizontal scaling means as more resources are needed, a more system in the form of nodes can be added, and this kind of requirement based scaling is called horizontal scaling. Whereas scale up means that if you have a system, let us say desktop, you require more resources, then you have to replace the desktop with, let us say that, a bigger machine. So, that is called scale up technologies, which is not required in support of today's workloads. Now, another thing is about incremental scalability, that is being supported by horizontal scaling, and fewer administrations means most of the operations are automatic, and the total cost of operation and total cost of ownership is there, and therefore, a lot of cloud providers, they provide this kind of solutions. Let us say Azure and AWS are some of the popular services by the cloud providers, avoid single point of failure and high speed. So, IoT data store is this kind of workload which requires this kind of features to be supporting. So, scale up and scale out. So, scale up is not needed in these kind of workloads, which is an IoT workload. Scale out is there. Scale out means the incremental grow your cluster capacity by adding more COTS machine, that is component of the shelf machine. This is the cheaper way of providing more resources for storage, and also it is can work over a long duration and phase in a fewer, that is a faster machines as you phase out with the older machines. And most of the companies who runs the data center and cloud, they follow this scale out technologies. Now, this key value stores also supports a model which is called a NoSQL data model. Let us understand what you mean by NoSQL. So, the full form of NoSQL is called not only SQL, and this necessary APIs to access this information is called get by key and put by key and value. So, some of the extended operations are, for example, CQL in Cassandra key value stores. So, in NoSQL, the tables are called sometimes column families in Cassandra and table in HBase and collection in MongoDB. So, table has different names in NoSQL database systems or in a data model. So, again I am repeating, column families, that is nothing but a table in a Cassandra, a table as a table in HBase, a collection as a table in MongoDB. So, all these are some form of a table, but with a different name in these kind of NoSQL database. RDBMS has a table, but here these tables are to be for unstructured data. So, maybe the data is unstructured, may not have the schemas, and some columns may be missing and some rows may be missing. So, this is not fit for the RDBMS. So, RDBMS type of databases is not the requirement of supporting this IoT use case, and it requires this kind of data store which is called NoSQL data store. Similarly, this NoSQL data store also does not require the join or a foreign keys and have the index tables like RDBMS. So, this particular details are explained here in this following illustration. For example, if the data is unstructured, you mean that no schema can be imposed and the data is organized in the form of a key value store. But let us take this example of a table, let us say Cassandra called column families. So, user table will have this following attribute: user ID will become a key and all other attributes will become the value. And here, since no schema is posed, so some of the row entries or column entries may be missing. So here you can see these are the column from some rows, they can be missing, and that is not a problem in NoSQL or unstructured data model. So these are all called column oriented storage. NoSQL system often use the column oriented storage. RDBMS store the entire row together, that is row oriented storage is RDBMS, which is not used much for IoT scenarios. So NoSQL system typically store the columns together or a group of columns together, and entries within the columns are indexed and easy to locate given a key and vice versa. So why this column oriented storage are so useful? It is useful for doing the range queries within the column are very fast, and you do not have to fetch the entire database, only those column entries are need to be fetched. For example, if you say that get me all the blog IDs from the blog table that were updated within the past month. So it will search in the last updated column and fetch the blog ID and so on. Let us go and see the design of Apache Cassandra. So Apache Cassandra is a distributed key value store. It is intended to run in a data center, also called DCs, and originally this Cassandra is designed at the Facebook. It is open sourced later. Today very important Apache project. Some of the companies that use Cassandra in their production clusters are blue chip companies like IBM, Adobe, HP, eBay, Ericsson, and newer companies like Twitter, and non-profit companies like PDS Kids. Netflix uses Cassandra to keep track of positions in the videos. So how do you decide which server a key value store resides on? So that means you say that this Cassandra data store is using the entire cluster, and entire cluster means it will be having hundreds and thousands of nodes in the cluster. So the question is, how do you decide which server this key value store resides on? That is called key to the server mapping inside Cassandra. So key to the server mapping inside Cassandra is supported with a concept which is called a ring based DST without other details of DST uses like finger table or the routing table. So key to the server is mapping is called the partitioner in Cassandra. So this is the example which you can see that if let us say you want to read and write a particular key, that is K13. So this particular request goes through a client module, and this particular ring will have a coordinator designated coordinator. So it will intercept this client request which is running at the node N80 when it gets the to resolve the key K13. What it will do, that is what is shown over here. So K13 will be now put on a hash function. So K13 will be now resolved for N16. So the data which is stored here in the form of a ring is replicatable also. So if it is K16, so the primary copy will be in the N16 node, and the next node, that is N32, will have its secondary replica, similarly N45. So there are three different entries. One entry will be given by hash function. So if you say that K13, if you apply to the hash function, it will give this kind of N16 entry, and it will give N32. So which is shown over here. So N32, and then maybe a backup replicas also will be supported. Now let us see if I say that a particular key value is stored or a key value entry is stored not at one place, but it is replicated. So what is that replication strategy, which is also called the data placement strategies, and this is very much needed to avoid the single point of failure. So replication strategy which is followed, which is applied in Cassandra, are of two types. first type is called simple strategy, the other is called network topology strategy. Simple strategy uses partitioner, of which there are two kinds of partitioner. One is called random partitioner, which is called like hash partitioning. The other is called byte order partitioner, which assigns the range of keys to the server. So byte order partitioner is easier for the range queries. So for example, if the query is get me all the Twitter users starting with A to B, so this is a kind of range query, and byte order partitioner is very good in resolving this range queries. The other type of strategy is called the random topology strategy. This strategy is used for a multi data center deployment. So it says that 2 replicas per data center and the third replica will be on another data center. So per data center, first replica will be placed according to the partitioner, then you go around the clockwise ring until you hit a different rack. So therefore, if you have 3 different replicas, so the first replica, if it is pointed to a particular data center, so this data center will have 2 replicas, which is organized in the following manner. So it has to be stored on a, let us say, first rack, and then it will be stored on another rack in the same data center. So the third replica will be stored on another data center. So a particular key value store, key value data will be stored in 3 different replicas, which are explained here with this particular rule. So 2 replicas per data center and third replica will be in a different data center. Now per data center, the first replica will be placed according to the partitioner, that is what we have seen, and then you have to go clockwise around the ring until you hit a different rack. So that will be in the same data center but on a different rack. So if a rack is not working, even then you continue to access the data. If the entire data center is down, you can continue accessing the data because it is available in the other. So this is called network topology strategy, and it is quite different than the simple strategy. Snitches means the map from IP to the racks and data center. So this is the next level of mapping which is needed from IP addresses to the racks and data center. So let us see how that is done in Cassandra. So this kind of mapping is configured in a configuration file that is called cassandra.yaml. Now some options are there for the snitches. The first is called simple snitch, that is, this simple snitch is unaware of topology, that is rack unaware snitch. Rack inferring snitch assumes the topology of the network by octet of server's IP addresses. For example, if the server IP address is 101.102.103.104, then you can understand that the first octet is, let us say, X, but the second octet 102 represents the data center and the third octet represents the rack within the data center and the fourth octet represents the node within the rack. So this kind of rack inferring is snitch, that means from the IP address you can know what is the topology of that particular network where this particular mapping of IP will takes place into the. So this particular property file snitch uses the configuration file. So let us say that you have an EC2 snitch. The EC2 is a particular service in AWS, that is Amazon Web Service Cloud offering. So EC2 snitch uses EC2, and EC2 regions is nothing but the data center, and the availability zone is nothing but the rack. So therefore EC2 snitch is an example of rack inferring snitches. So let us see about the writes. So writes need to be log free and fast, no reads or the disk seeks are needed. When a client sends the write to one of the coordinator node in Cassandra cluster, then the coordinator may be per key, per client or per query basis that we have shown you in the previous diagram. So, per key coordinator ensures the writes for the keys are serialized and the coordinator uses partitioner to send the query to all the replica nodes responsible for that particular key. So, when an X replica respond, the coordinator returns an acknowledgement to the client. So, what is this X? So, to make it more understandable is that you know that every data is replicated 3 times. Now, if the value of X is less than 3, let us say 2, that means if the 2 replicas, if they respond to the coordinator, if the 2 replicas respond but not 3, even then if the value of X is set as 2, so this means the coordinator will return an acknowledgement to the client and rest of the third replica will be handled later point of time by the coordinator. Now, writes always writable, that is hinted handoff mechanism is used for the write operations. So, if any replica is down, the coordinator writes to all the other replicas and keep the write locally until the replica comes up. So, when all the replicas are down, the coordinator, that is the front end, buffers the write for the first few hours. So, this is called hinted handoff mechanism. Now, then we are going to see in the write one ring per data center is followed as the resources for data storage. So, per data center coordinator is elected to coordinate with other data center and the election is done via the zookeeper which runs paxos, that is a consensus variant protocol. So, write at the replica node, on receiving the write it logs it to the disk commit log for failure recovery, make the changes in the appropriate memory table called mem table. So, in memory representation of multiple key value pairs, typically it is used the append only data structure, that is very fast to support the fast write operations. Similarly, the cache that can be searched by the key and write back as opposed to the write through. These are some of the important implementation details which Cassandra uses to make this very fast. So, later the mem table is full or old, then it will be flushed to the disk. For that, as far as the data file is concerned, it is nothing but supported as the SS table, which is called sorted string table, that is a list of key value pairs which are sorted by the keys. SS tables are immutable, that is once created they do not change, and index file, that is an SS table of the key and the positions in the SS table pair. It also uses the Bloom filter for efficient searching. Why? Because you know that so many data files will be now stored, so many SS tables will be created. So, we are skipping the Bloom filter, but nevertheless Bloom filter will make it the retrieval of that particular key very fast through the SS table. So, Bloom filter is a compact way of representing a set of items and checking for its existence in the set is quite cheap and some probability of false positives are there. So, that is that the item not in the set may be checked true as being in the set, but it is supporting never the false negatives. So, false positives is doable in most of the applications, but not the false negatives. So, Bloom filter is good to support the fast retrieval. Now, then there is a operation which is called the compactation. So, data updates accumulate over the time and SS tables and logs need to be compacted. So, the process of compactation merges the SS table by merging the updates for a key. It runs locally and periodically at each server. the deletes. So, deletes of an item is not done right away, but it will be added to the tombstone, to the log, and eventually when the compactation encounters tombstone, it will delete the item. Reads similar to the writes, but except the coordinator can contact X replicas, that is in the same rack. Coordinator sends the read to the replicas that have responded quickest in the past. So, when X replicas respond, the coordinator returns the latest timestamp value among those X. So, X is configurable. So, for example, if you have 3 replicas, and if let us say that the quickest one has responded and the value of X is equal to 1, then this particular information will be passed on to the client in the read operation is completed. Now, coordinator also fetches the values from other replicas. So, to check the consistency in the background, it will initiate the read repair if any two values are quite different. So, this mechanism seeks to eventually bring all the replicas up to date. So, at a replica, the node may be split across multiple SS tables, that is quite possible. So, reads need to touch multiple SS tables and the reads may be slower therefore than the writes, but is still quite fast in comparison to the RDBMS. So, membership. So, any server in the cluster could be the coordinator, and we have seen how the election of that coordinator happens. So, every server need to maintain a list of all other servers that are currently in the server, and the list to be updated automatically as the server joins, leaves or fails. So, this cluster membership is done through the protocol which is called a gossip style protocol. So, Cassandra uses gossip based cluster membership. Cluster membership means that it has to keep a list of, or it has to update the operations such as when a server joins, leaves and fails in this particular ring, that is done by the cluster membership. So, suspicion mechanism is also there in the Cassandra, suspicion mechanism to adaptively set the timeout based underlying network and the failure behavior. So, accrual detector means failure detector outputs a value representing the suspicion, and the application set an appropriate threshold for that. So, we are not going in detail about PHI calculation. So, that is used for the gossip protocol settings. So, therefore, let us compare the Cassandra versus RDBMS. So, MySQL is one of the most popular at a while. So, if let us say that we want to compare the Cassandra versus RDBMS on data which is called 50 GB data. So, what we have found out that MySQL writes usually takes 300 millisecond on average. Reads in MySQL that is in RDBMS takes 300 milliseconds, whereas in Cassandra the writes will take only 0.12 milliseconds on an average. So, write is much faster compared to the RDBMS. Similarly, reads is 15 milliseconds in Cassandra, whereas your RDBMS supports 350 milliseconds, that is much at a lower time, that is very quick operation. So, magnitude of orders of magnitude, this Cassandra is faster. So, what is the catch and what do we lose out of this particular fast access? To understand this difference, we have to understand the theorem which is called a CAP theorem. So, CAP theorem is proposed by the Eric Brewer from Berkeley, subsequently which is proved by Gilbert and Lynch. So, in a distributed system, you can satisfy 2 out most 3 guarantees. So, what are these 3 guarantees, which only 2 of them can be supported according to the CAP theorem. So, the first one is called consistency, that is, a node see the same data at any time, or the reads returns the latest written value by any client, that is called consistency. Availability means the system allows the operation at all points of time and the operations return quickly, that is called availability. Third one is called partition tolerance, that is the system continues to work in spite of network partitions. So, these three are important factors, but CAP theorem says that not three or not all three can be guaranteed, only 2 out of the 3 is guaranteed in this distributed system situation. So, let us see which is more important for different applications. So, let us see one by one. Availability means that the reads and writes will complete reliably and quickly. So, measurements have shown that 500 milliseconds increase in the latency for the operations at Amazon.com or at Google.com can cause a revenue 20% drop. So, why? Because at Amazon each added milliseconds of the latency will imply a revenue loss. Why? Because the customers will churn and they will prefer some other website which is very fast responding. So, availability is most important, that some of these e-commerce websites, or let us say that for IoT data also, if the analytics is so important, that is it is monitoring, let us say, this logistics of this company called Amazon.com, and let us say that this particular latency is added, that is it is showing, so availability has to ensure at all points of time. Similarly, the user cognitive drift. So, if more than a second elapses between the clicking the material and appearing at the, so user's mind will change. So, this is governed by thing which is called service level agreements. So, the providers, they have to predominantly deal with the latencies which are faced by. So, availability again is an important factor in running this particular business or on this data store, using the data store. So, the functionality of the data store is very important, because all the data is to be fetched out of this data store. So, availability is a key aspect. The second important aspect is called the consistency, that is all the nodes see the same data at any time, or the reads return the latest written value by any client. So, this is very important as far as the banking applications are concerned. So, when you access your bank or the investment account via multiple clients, whether it is a laptop or you are accessing through a mobile phone, so you want these updates to be done from one client to be visible to the other clients. So, whether that means whether you are using the desktop or a laptop, all the updates has to show the same data at any point of time. So, when thousands of customers are looking to book a flight, and all the updates from any client should be accessible by the other. So, this consistency also is sometimes important, but in the situations like banking applications, reservation situation and so on. So, let us see the third aspect, which is called a partition tolerance. Partition can happen across data center when the internet gets disconnected, that is due to the internet router outages or undersea cable cut or DNS is not working. So, these partitions can happen across the data center due to these kind of disruptions. So, partition can occur within a data center also, for example, when in the condition of a rack switch outage, you still needs a desirable system to continue functioning normally under any of these situations of the outages. So, the CAP theorem fallout says that the partition tolerance is essential in today's cloud computing and all the services which is supported, whether it is a IoT system and so on. So, the CAP theorem implies that the system has to choose between the consistency and availability. So, once you fix that partition tolerance is an indispensable characteristics. So, therefore, now you have to choose between the consistency and availability. Now, let us see the Cassandra. Cassandra chooses availability over the consistency, and consistency it does a compromise and it is called an eventual consistency. So, therefore, Cassandra says that it compromises with the consistency, and the consistency which Cassandra provides is called eventual or the weak consistency, whereas availability and partition tolerance is provided. So, traditional RDBMS has the strong consistency over availability under a partition. So, let us see the CAP theorem trade off. So, consistency, partition tolerance and availability is shown by this particular triangle. So, let us see any two you can choose out of 3. So, let us see about the Cassandra. So, Cassandra chooses partition tolerance and availability, which is shown over here. Similar database or NoSQL data store or React, Dynamo, Walmart. So, these are all systems which are used in IoT data store. Now, regarding consistency, so if the consistency is important in the banking application, so if let us say consistency is needed and partition tolerance is a must, then it has to now compromise with the availability. So, therefore, you might have seen in the banking online application that the server is not available, but that means whenever it is available, it has to ensure the consistency and partition tolerance. So, the example of a database is which stores or which satisfies consistency and partition tolerance, they are HBase, then Hypertable, Bigtable and Spanner. So, most of these are from Google. If consistency and availability both are to be ensured, then it is RDBMS. So, therefore, the starting point for NoSQL Revolution is that it is a distributed storage system and can achieve at most 2 out of 3, that is called a CAP theorem. So, when partition tolerance is important, you have to choose between the consistency and availability. So, we have understood very details about the CAP theorem trade off. So, let us see how the eventual consistency is supported in the Cassandra. So, eventual consistency, that is, if all the writes stop to a key, all the writes to a key, then all its values, that is replica, has to converge eventually. This is means that eventual consistency. Now, if the writes continue, then the system tries to keep converging. So, there will be a wave of update values which is lagging behind the latest value sent by the client, and eventually they are trying to catch up. So, eventually it will achieve the consistency, but not instantly. So, may sometimes return the stale values to the client if many back to back writes are there, but it will work fine for this kind of situation, let us say IoT and all, when there are few periods of the low writes and system converges quite quickly. So, if you see RDBMS versus key value store, so RDBMS supports the ACID properties for the transaction, that is atomicity, consistency, isolation and durability. Now, in contrast, if you see the Cassandra or a key value store like Cassandra, it uses for the transaction the property which is called a base property. So, base stands for basically available soft state eventual consistency, means that it ensures the availability, it ensures the partition tolerance, but the consistency is eventual. So, base means basically available soft state eventual consistency, which prefers availability over the consistency. So, consistency in Cassandra, if you see, Cassandra has the consistency levels. So, clients allowed to choose the consistency level for each operation, that is for the read and write. So, consistency level the client can choose, that is configurable. If it is any, that means any server may not be the replica, that is the fastest one if the coordinator caches the write and quickly replies to the client. So, all means all the replicas the update has to be there. So, that means it is the condition of consistency, ensuring a strong consistency, but it will be quite slow. So, one means that at least one replica is faster than all, but cannot tolerate the failure. So, there is a quorum. So, quorum across all the replicas in all the data centers. So, in a nutshell, so quorum means that a majority which is more than 50%. So, any two quorums may intersect, you can see over here. So, this example shows the 5 different servers. So, the majority among 5 is at a time 3. So, the client 1 does the write in the red quorum. So, this is the red quorum, then client 2 does the read in the blue quorum. So, at least one server in the blue quorum returns the write. So, the quorums are faster than all, but it still ensures the strong consistency. 5 replicas of a key value store is shown in this example. So, quorums, let us go in more detail. So, several key value store like NoSQL, React and Cassandra use the quorums. for the read operation. So, client specifies the value of R here in this case, which is less than or equal to n, that is the number of replicas of that key, and R is the consistency level. So, the coordinator waits for R replicas to respond before sending the result to the client. In the background, the coordinator checks for the consistency of the remaining n minus R replicas and initiate the read repair for eventual consistency. So, as far the writes are concerned, writes comes into the two flavors. So, client has to specify the value of W, which is less than or equal to n. So, W means the write consistency level. So, client writes a new value to W and to W replicas and returns in the write. So, two flavors are there. So, coordinator blocks until the quorum is reached. Asynchronous means that it just writes and returns. So, it depends upon these kind of settings. So, R is the read replica count, W is the write replica count. So, two necessary conditions has to ensure that read plus write should be greater than n and W is more than n by 2. So, we have to select these values based on these applications. When W is 1 and R is equal to 1, then very few writes and reads are there. So, and when W is n and R is 1, then it is great for read heavy workloads. When W is n by 2 plus 1 and R is also n by 2 plus 1, it is great for write heavy workloads, and when W is 1 and R is equal to n, it is great for write heavy workloads with mostly one client writing per key. So, these are all very much design issues which are needed to support the IoT applications. So, Cassandra consistency level. So, Cassandra is allowed to choose these consistency levels, which we have already some of them we have already stated about the quorum and the local quorum and each quorum. So, the types of consistency which Cassandra offers is called eventual consistency. Now, we may ask are there any other type of weak consistency models. So, let us go ahead with the consistency models which are supported across different NoSQL data stores including the IoT databases. So, consistency level on one side is a strong consistency, the other side is called eventual consistency. Sometimes if it is closer to eventual consistency, then the reads and writes are then the faster reads and writes it will support. If it is towards strong consistency, then reads and writes are slower, but it will support the strong consistency. So, it is a spectrum of different consistency models between eventual and strong. So, Cassandra offers eventual consistency. So, if the write to a key stops, all replicas will converge. Originally from Amazon's Dynamo and LinkedIn's Vodal Mart system supports that. Now, let us see what are the other consistency model which are now available or evolving. Very close to eventual is called causal consistency, then red blue probabilistic per key CRDT. There are many other models available. So, there are many more databases available in the by different providers. It depends upon the application. So, per key sequential is all the operations have global order. CRDTs means commutative replicated data types. So, data structures for which the commutated writes give the same results. So, for example, the integer values, if it is, then the operations plus 1 is allowed, whether a plus b or b plus a. So, commutative operations commutative operations are very much needed to support this type of consistency. So, eventually effectively servers do not need to worry about these consistencies. Red blue consistency, that it will rewrite the client's transaction to a separate operations in a red operations versus the blue operations. So, blue means it can be executed in any order in any data center. Red operations need to be executed in some order. So, these are all this is called causal consistency, that is the reads respect the partial order based on the information flow, and this is developed by Princeton CMU. It is shown over here. So, strong consistency model supports the property which is called linearizability. So, each operation by the client is visible or available instantaneously to all other clients. So, this is called linearizability. So, instantaneously is in the real time. So, without any lag. So, sequential consistency which is supported by the Lampert is the result of any execution is the same as if the operations are all the processors were executed in some sequential order and the operations of each individual processor appears in this sequence in the order specified by the program. So, here the to find out the value, the reasonable ordering of the operations can be can reorder operations that obey consistency at all the clients across the clients. So, the transaction, that is the ACID properties, if let us say that you want to follow for NoSQL databases, or then a new kind of development which is happening around the cloud providers. So, they are calling it as new SQL. So, this is new SQL means that it is the NoSQL data store and also it supports the ACID properties. So, the examples are HyperText by Cornell and Spanner by Google and Transaction Chain by the Microsoft Research. So, these are the newer developments called new SQL. So, we have so far seen the NoSQL and newer SQL is in line. So, let us conclude this is that, so we have started with the motivation of providing the storage technologies for IoT workloads. So, what we have found out is that this hot data analytics, cold data analytics, these are some of these, and warm data analytics, the three type of analytics is required to be supported, and for that storage system technologies are required in place. So, for IoT, let me write down IoT data stores requires hot data analytics, cold data analytics and warm data analytics. So, what we have so far seen to support that, we have seen here the design of IoT databases, and in that line sometimes traditional databases or RDBMS can also be used, which is having the strong consistency property and offer the ACID properties. However, the today's workload, which is so many number of sensors are sending the data to the cloud, requires a time series data to be stored somewhere. Don't require these strong guarantees, but do need fast response time, that is the availability. Unfortunately, the CAP theorem says that these all three, that is consistency, availability and partition tolerance, is not possible for all three to be abide by. Therefore, we have seen a design of a system, that is the key value store, that is called NoSQL system by the Cassandra, which offers base property, basically available soft state eventual consistency. And this kind of system, which is widely used in many of the production clusters, and also can be used here for IoT data store. So, it supports the eventual consistency, and a variety of other consistency models can also be tunable here in Cassandra that we have seen. We have also discussed the design of Cassandra and other different consistency solutions, which is applicable for IoT data store. Thank you.